In this video, we'll go over the fundamentals and intuition of simple linear regression. Essentially, simple linear regression helps us to predict the value of one variable y based on another variable x. Generally, we refer to x as the independent variable and y as the dependent variable. So why it is called independent? The term independent refers to the fact that you can modify it on your own without any external influence. So you are free to assign any value to it as per your requirement. In simple linear regression, our goal is to establish a relationship between the two variables x and y. So by modifying the x independently, we can predict the corresponding value of y using our simple regression models. So why it is called simple and linear? The term simple is used to analyze the correlation between only two variables. When the independent variable increases or decreases, the dependent variable changes in a linear fashion. At the beginning of this playlist, we are learning about simple linear regression. So as the name suggests, it deals with the relationship between only two variables x and y. However, as we progress, we will explore more advanced regression techniques. One such technique is multiple linear regression model, which deals with more than two variables. Now let us take an example to explain the concept of why we use linear variables. So let us assume you own an ice cream cart and want to establish a relationship between the outside air temperature and your daily revenue. To achieve this, you collected the data points throughout the year. For instance, on a day when the outside temperature was 24 degrees Celsius, you earned $534. On the another day, when the temperature outside was 26 degrees Celsius, you earned $625. The goal is to establish a mathematical model that predicts the revenue for any given day based on the temperature. So we measure the temperature outside and use that data to predict the daily revenue at the end of the day. So this is where simple linear regression strategies come into play. So let us go ahead and actually plot these points. Now let me try to explain this better in this graph. So on the horizontal x-axis, we have temperature in degrees Celsius, while on the vertical y-axis, we have the revenue. So assume that all the data points for temperature and revenue have been plotted on this graph. So as we observed that as the temperature increases, so did the revenue. So our objective was to derive a straight line, which we call the best fit line, that could accurately describe the data points and fit them well. So this line is the best representation of the correlation between temperature and revenue. Simple linear regression model establish a relationship between two variables x and y. So let us take a closer look at the mathematics behind it. To begin with, we have two variables, temperature and revenue, and we plot all the data points. So our goal is to obtain the best fit line that can pass through the data. We know that the equation of a straight line can be represented as y equal to b plus m times x, where x is the independent variable, which in our case is the temperature in degrees Celsius. We can change this variable independently, and y is the dependent variable, which in our case is revenue. So our objective is to determine the value of m and b, which will give us a simple linear regression model. To clarify, developing a mathematical model involves determining the value of m and b. Simple linear regression is especially useful because it allows us to predict the change in our daily revenue based on change in temperature. Once I have the equation of a straight line, I can easily describe and forecast these changes. So for example, it is now possible for me to determine the impact of temperature on my revenue with greater accuracy. For every 10-degree rise in temperature, I can predict a $20 increase in my revenue. So it is important to keep in mind that this is simple example of linear regression and does not take into account all the variables that may affect the revenue. However, this method provides a useful starting point for analysis. In the upcoming playlist, we'll be delving into more advanced topics such as artificial neural networks, multiple linear regression, polynomial regression, and others. However, before we get into that, it is important to build a strong foundation and have a good grasp of basics and the underlying intuition. This will help us to understand the more complex topic that we'll be covering later on. The important issue is to consider how to utilize the model. So after obtaining the value of m and b, the question arises, what's next? So as previously mentioned, the equation for the model is y equal to mx plus b, where x is the independent variable, y is the dependent variable. So here it is evident that we can obtain the coefficient m and b. The coefficient m represents the slope of the line, which is calculated by dividing the change in y by the change in x. On the other hand, the coefficient b represents the point where the line intersects the y-axis. Once the equation is obtained and the value of m and b are determined, the trained model can be used to predict revenue in dollars based on outside air temperature. This means that on any given day, if the temperature is measured, for example 45 degrees Celsius, the revenue can be predicted to be $1,000. It is worth noting that the current temperature may not have been encountered by the model before. This is one of the advantages of machine learning. The model is trained on a set of data points to create a fit that can be used for predictions. So this training data is what enables the model to make accurate predictions. So after developing the model represented by the red line, I can deploy it to predict the future measurements or values. This is extremely powerful because the model is able to make prediction based on data it has never seen before. It means that I can generate a new temperature, for instance 60 degrees Celsius, even on an unusual day. Then I can predict the revenue, let's say it will be $12,000, which we never had as a data point before. So here in this slide I have two equations, y equal to 3 times x and y equals to 15 minus 10 times x. So let us take the first example. So if you try to match the given scenario with our equation y equals to mx plus b, which represents a straight line. So there are few things to consider over here. Firstly, there is no value for b, which implies that in this case b is equal to 0. This makes sense because the straight line passes through the origin, which means that there is no y-intercept. Therefore, b is 0 in this scenario. The second point refers to the slope of the line, which is represented by the letter m. In this case, m is positive 3, which means that as the independent variable increases, the dependent variable will also increase. This can be explained with the help of the line or model, where we can see that x increases, y also increases. So let us take a look at the second equation. So unlike the previous equation, this equation has y-intercept, which is 15. This means that the distance between the line and the y-axis is 15 units. As you can see from the graph, the slope of the line is negative. This implies that as the value of x increases, the value of y decreases. In other words, there is an inverse relationship between x and y. The negative sign in the equation confirms this. Therefore, we can conclude that the two variables are inversely proportional to each other, as indicated by the negative slope. So that is all I have for this video. I hope you have enjoyed it. In the next video, we are going to cover the least square method, which we will use to obtain the coefficient m and b. So stay tuned for that. So I'll see you in the next video.